Hi there everybody, it's the ML-Universe. Hope everything is fine. I'm a Rashman who brings follow some more experience. And today we're gonna communicate with you about recommended systems and how to create them and what are they. And let's start out coming up, as they say. Okay, first, the recommended systems, it is ML systems. ML systems, it is machine learning systems. So we have inputs and we have outputs. And outputs are probabilities and different types of forecasts and guesses and predicts for the future what will be and what are the percentage of it, maybe at 0.668 or maybe 0.67 or maybe 0.53 and etc. It will be the chance. Actually, it will be the 53% or maybe 87% and etc. So it is ML system, and on the inputs it is our big data, it is our tabular data or time series data. And what are the approaches for creating the recommended systems? And actually, recommended systems, it is the specific systems that are ranking and different types of recommending to us something. Actually, ranking and recommending and ranking. It is, for example, could be the search engine when we are googling something, typing, and then we have the specific products and services and different types of things that we can see. Actually, it could be the content, for example, on YouTube. Yes, you can see something, or maybe on another services you can find them. So how to create and how to create them, and how to design, how to develop, how to establish it, and what are the approaches? We have three different approaches. First, it is collaborative filtering. Second, it is content-based filtering, and third, it is our hybrid filtering. And it is our approaches. Actually, collaborative filtering, what is it? Collaborative filtering, it is when we create this system, actually recommend a system by using the collaboration of users. What are the collaboration in this context? It is the specific. I imagine that you have a friend and you have different mutual interests. For example, you are listening to the same music, you are watching the same movies, you are playing the same games. For example, it could be the Genshin Impact and also the Brawl Stars and Fortnite and etc. And also you have with your friend you have your interests and your friend has his own interests. And actually your interests and his or her interests, they are intersecting in some percentage. For example, it will be 80% of intersection, and it means that you are mutual with your friend on 80%. And actually it means that if you are mutual, for example, in this type of percentage, then you could be recommended, the content will be recommended to you by his set that he watches, or her set and what she watches. Okay, and for example, you play 3 games, he plays 4 games, and actually 3 games, they are intersecting each other. And this one, the 4th game of him, it will be recommended to you. It is the collaborative filtering. About content-based filtering. Content-based filtering, it is based on the content, actually, on the specific insights that we have inside of the data that we have inside of the movies, or maybe TV series, or games, or music, actually. Oh, something is here, flew around to me. It is hair, a small piece of hair. Okay, and the specific content-based filtering approach, it is when we look at the data and we see the similarities inside of the data itself, not on the specific users' preferabilities. It will be for the content. For example, you are listening to Hans Zimmer. Hans Zimmer is the composer. And when you are listening to the Hans Zimmer, you can notice that there are a lot of violin, you can notice there, and also drums. And you will see, it means that maybe something that contains the violin or maybe cello and drums, it could be recommended to you too. The same with specific genres of music. For example, pop punk, we have Blink-182, My Chemical Romance, Paramore, and several other bands such as, and artists such as Avril Lavigne and Machine Gun Kelly and etc. And actually they are almost the same in their contents, in terms of the music and in terms of the kind of vocabulary that they are using, in terms of the back of words that they are using. Okay, continuous back of words, distributional back of words, yes, and word-to-vec technologies are connected here, and also doc-to-vec technologies. It is NLP, NLG, natural language processing, natural language understanding, natural language generation. And we have the approach when we look at the content and when it is, again, intersecting to each other. One music is similar to another in some percentage. If threshold of the kind of allowance will be overstepped, then we can recommend something. Threshold is the specific number that when something goes over it, then, okay, recommend it. For example, 70%, it could be our threshold, or maybe 14, it could be threshold. It is super mega kind of small similarities between music, but it is similar too. Or maybe it could be 80%, 70%, 50, 60, and 90%, 95, 99. Then recommend something like this. But actually 99 is really super mega accuracy that you can use. Okay, hybrid. We talked already about collaborative filtering and also content-based filtering. And the third approach is our hybrid filtering. Hybrid is the mix of two previous approaches when we connect them and we use them in some percentage. For example, we will use by users by our collaborative filtering by 30% and another approach by 70%, or maybe 20 to 80, or maybe 50 to 50, or maybe 60 to 40, and etc. It is the same thing. Actually, it is all about the percentage of usage of different approaches. So, thank you a lot for watching this video. Hope you enjoyed it, and let's repeat what we learned already about recommended systems. Recommended systems, it is our ML systems, machine learning systems that are giving, they are providing to us data, some data and some things actually. They are recommended to use services, or maybe it could be products, or maybe multimedia content. And they are using different types of approaches and also ranking. They do ranking, and they are using different types of approaches such as collaborative filtering, content-based filtering, and hybrid filtering. Also, they can use different types of algorithms such as merge sort, quick sort, bubble sort, heap sort, tree sort, radic sort, swoosh sort, bogus sort, and also GNOME sort and others, insertion sort, selection sort, and search algorithms, breadth first search, depth first search, and brute force search, best first search, and also page rank, trust rank, and other things that are kind of in algorithmic world. Yes, you know what are the algorithms actually. It is kind of upper than this, and it is you can use classical methods, and also you can use these three that are related already to this technology of recommended systems. Also need to mention item-to-vec technology. Item-to-vec technology used here too. It is when we use specific items and we kind of transform them to specific vectors. For example, when we use word-to-vec or doc-to-vec technology, when we transform actually the words and specific documents, specific texts into the specific vectors. Vectors as linear algebra objects, as we can describe. Okay, thank you a lot for watching this video. Enjoy your day, go forward, everything depends only on you, and see you next time. Keep yourself daily. Bye. You're a nice guy, girl. Bye.